we can highlight for dividing. So dividing two functions, there's our notation. I've also seen this notation like that on an exam. Again, if you see the not nice notation, take the time to switch it to the nicer notation. So this just means f of x divided by g of x. And the thing that's different with domain is our red function is restricted to be x is bigger than or equal to 2, but our green function also has an asymptote. Because you're dividing by the blue function, wherever the blue function is equal to 0, you will get, that is not my asymptote line, you will get an asymptote. And as we saw in the pre-example, if both your original functions are 0 at the same place, that's the situation where you get a hole in your graph. So if we go to example 2, we've got f of x is the square root of x and g of x is x minus 2. State the domain and range of both of those. Again, I'll color code them. F of x in green, g of x in blue. So in part A, the domain of f of x, well, it does have a restriction. We're not allowed to take the square root of a negative. Again, you might draw a quick sketch of these graphs. And drawing those quick sketches allow you to say, I know that the range of my green graph is y is bigger than or is equal to 0. The domain of a line is everything. The range of a line is everything as well. Part B, given q of x is f of x divided by g of x, if we want to write an explicit equation, we have to replace the f of x with the square root of x and replace the g of x with x minus 2. The domain for this one, again, look at your explicit equation and say, are there any restrictions? Yes. You can't take the square root of a negative. So the domain of this one will also be x is bigger than or equal to 0. But we also have a non-permissible value at 2. So we have to add to our domain that x can't equal 2. The range of q of x, again, this is harder to find. We have to graph this. We've never graphed a square root over a line. That's not one of the things that we've hit in our polynomials function. So in that case, what we would do is we would start by graphing our original line, which was x minus 2, which has a line with a y-intercept of minus 2 and a slope of 1. And our square root graph, which I'll graph in green, which looks like this. Okay? Some important things to notice, that on both of these lines, we have this point 4, 2. And if I wanted to do the green graph divided by the blue graph at my non-permissible value, that is where I'm going to have my asymptote at x equals 2. What happens when I do, and I'll draw q of x in black, 0 divided by anything is 0. Here, okay, remember when either of the functions is equal to 1, something important is going to happen. So here, when the green function is 1, 1 divided by a negative 1, that'll be negative 1. and this part of my graph will go down towards my asymptote. The points where they both intersect, well, 2 divided by 2 will be 1. This graph will also have an asymptote at y equals 0 as x gets really big, because the degree is bigger on the bottom. You can think of the top as an x to the half, and here I have an x to the 1. So whenever our degree is larger on the bottom, we have an asymptote at y equals 0. And this part of our graph, whoops, wrong color. This part of our graph will look like this. And here's the difficult part. What's the range of that graph? Y is an element of all reals, and you wanted to say y can't equal 0, but it did equal 0 right there. So it ends up being everything. A very weird looking everything. Now generally on the exam, they're not going to ask you these difficult range questions. They like to ask more of the domain questions. Questions for practice on this one. 6, 13, and 16.